Hello, in this video I'm going to be going over a relatively straightforward parametric equation from OCR A level 2019 paper 2. So it's early on in paper question 3. Particularly the first bit is pretty standard and fairly straightforward things. We probably recognise it's going to be a circle because we've got a 2 cos theta and a 2 sin theta there, so suggesting it's a circle because of the sine and the cos and the equal coefficient here. So we've probably seen things like this before, and it's going to involve the using the identity sine squared theta plus cos squared theta equals to 1. Okay, so it's going to be involving using that. So I'm going to rearrange this and then basically somehow use this identity. It should hopefully be relatively easy to see. It's right, x minus 3 is equal to 2 cos theta, and y plus 4 equals to 2 sin theta. Let's square this out, and because I'm going to be using sine squared plus cos squared equals 1, so squaring them, x minus 3 squared is equal to, don't forget to square the 4 and the 2 to get 4, so that's cos squared theta, and y plus 4 squared is equal to 4 sine squared theta. Let's say I could isolate the sine squared theta and cos squared theta and put it into here, but that just involves kind of getting a fraction only to multiply it out. So we should be able to see easily that adding these two equations is going to give us what we want, because we're going to get sine squared theta plus cos squared theta. So x minus 3 squared plus y plus 4 squared is equal to 4 cos squared theta plus 4 sine squared theta, which we probably can see already is equal to 4, but I'll do this just in case. Oh, don't want a 4 there. And we can see that we know that sine squared theta plus cos squared theta is equal to 1, and we've got 1 there. So we have, as I say, I'm hoping that most of us will recognise this as a circle, because we've seen this kind of thing before, equals to 4. And then a very, very easy mark to work out the centre of the circle. The centre the x coordinate will be when this is equal to 0, which occurs when x is equal to 3. And the y coordinate will be when this is equal to 0, which is when y equals to minus 4. And then we got r equals to 2 because r squared is 4. Okay, so that's pretty, I say only 3 marks, but pretty straightforward stuff. Now the next question kind of like changes the equation, so be careful. I started doing this, was dealing with the original equation, which is, so it's a bit unusual to change the equation completely, but not that unusual, so read the question carefully. This won't be a circle, by the way, it'll be an ellipse, because x varies between 2 and 4, and y varies between, x varies between 4 and minus 4, and y varies between 2 and minus 2, so it's going to be kind of elongated like that. So it's going to go like that, so with 4 and minus 4. It's not asked for a sketch, but just offering one anyway. And then we've got this going between minus 2 and 2, and what we're being asked for is we were given some kind of tangent when t is equal to t is equal to pi over 6, and where it crosses the x-axis. Okay, so we need to differentiate first. So we have dy by dx. Well, we need to find for dy by dx. We need dy by dt and dx by dt. Dx by dt, we've got 4 cos t here, so dx by dt, differentiating cos t with respect to t, is minus 4 sine t. And dy by dt, differentiate sine t with respect to t, is cos t, so we got 2 cos t. So divide the two, we've got dy by dx is the division of those two, because that's dy by dt over dx by dt, and that equals to 2 cos t over minus 4 sine t. So that equals to minus half, because the 2 cancels there, and that's going to be a cot t. We don't need to write it as cot t, we could write it as 1 over tan t, or just keep the cos t and sine t there because we're not asked to simplify, but I've written it that way because it's kind of broken it down a bit. We need to find a gradient of that, so we've got dy by dx when t is equal to 1/6 pi. So that's equal to minus a half of cot pi over 6. Okay, so the thing is, the cot pi over 6 is 1 over tan pi over 6, which is what you can get on the calculator, but we should know this. Tan pi over 6 is 1 over the square root of 3, so cot pi over 6 is square root of 3. So that equals to minus square root of 3 over 2. Obviously we also, because what we need is we need the x coordinate and y coordinate as well. So when t equals to 1/6 pi, x is equal to 4 cos pi over 6. Cos pi over 6 is square root of 3 over 2. So that's times by 4, so that's 2 the square root of 3. And y equals to 2 sine pi over 6. Sine pi over 6 is half, so times that by 2 and we get 1. Okay, so we've got all we need here really to work out the equation of our line, because don't forget where we were. We've got some ellipse kind of shape. You don't need to actually, but it's useful to picture it, but you don't need the sketch. And what we're doing is we're finding out where this crosses, which involves finding the equation of this, or finding something which would equation for that, and then equating y equals to 0. Okay, so we know the gradient now, and we know the coordinate of this point. The coordinate is 2 the square root of 3, 1, and we know that m equals to minus the square root of 3 over 2. So let's rub this out now. So we got the coordinate that we need to work on is 2 the square root of 3, 1. So I'm going to use y minus y to work out my equation. I know other people have different strategies, which is kind of okay, although this is particularly useful here because no, we're not actually asked for the equation of the line, we're asked for when it cuts the x-axis. Okay, we're asked for when it cuts the x-axis, so therefore we can just put, we don't need to simplify the equation. We can just put it into here and then work from there. So y minus y1, so that's y minus 1, y minus 1 is equal to m, which is minus square root of 3 over 2 times x minus 2 the square root of 3. But the thing is, we want where it crosses the x-axis, so we don't need to mess around and simplify this. So it's useful when we're not asked to simplify it, just use the equation and sub in what you want at this point. It would just be easier. So when y equals 0, so that gives us minus 1 is equal to minus square root of 3 over 2 x minus 2 square root of 3. And so we can just rearrange this. Now I'm going to get rid of the negative and maybe cross multiply a bit. So we've got 2 over the square root of 3 is equal to x minus 2 the square root of 3. So that gives me x equals to 2 the square root of 3 plus 2 over the square root of 3. We could use our calculator at this point, I suppose. I mean, I'm so used to not using it, I've just rationalized that, but that's going to be equal to 8 the square root of 3 over 3. So that's our coordinate where it crosses the axis. So that's 8 the square root of 3 over 3. 0. That's it. So relatively straightforward question. Probably do some more videos on some slightly more involved questions than that. Okay, because hopefully that wasn't too bad. Okay, hope you found it useful. Bye.